second. Let me just say something here. I think Ben and Jamie know. This whole area of deep learning has been an epidemic with the accounting firms. Every accounting firm is putting many millions of dollars into Watson and that type of thing. Okay. Now the neural net technology, ANN, artificial neural network, had been around for a while. And although you talk about neural networks and anything, it's basically an algorithm, one of the machine learning algorithms. The difference of the work today is that we have much more computing and much more storage, and we can do this layered neural networks, okay? And so this is what Sophia is doing. And you better be ready because there'll be a whole epidemic of these articles in the market area trying to apply ANN into computer data and et cetera, et cetera. So we are just a little bit ahead, and I hope that Ms. Sun here gets her papers in the journals before someone else, because this is it's just a question of time. This is like I used to say about textual analysis, and took a little bit longer than I thought, but not much longer. This is going to be an explosion. And the big problem, I think, in this area of research is that we are not like PwC that can put millions of dollars in collecting data. And so therefore, Sophia has to find places that you can pick up the data for free, correct? Okay, and when she finishes up, let's talk a little bit more about this line of research.
So we focus on the sentence feature, and in order to extract sentence feature, we're using deep learning technology. And in order to demonstrate the effectiveness of this technology, we did a comparison between the deep learning and the back-and-forth approach, which is very popular text mining approach, and has been widely used for many years. And so for this paper, I'm trying to give you a little bit background about the deep learning. But before that, I want to say that this paper is motivated by the fact that deep learning has applied in many areas, and especially for the big data analysis, like the image identification, speech recognition, and text classification. It hasn't been applied to auditing yet. So we are trying to use that technology to apply to audit with the text to see if we can get some verbal things from. So another important motivation for this paper is that from the past literature, we found that the prediction model doesn't perform very well because the sample size is not very large and the prediction accuracy is not very good. So we try to bridge this gap by doing this research. And now let's do some introduction of the deep learning. So basically, deep learning try to simulate how the human brain thinks and learns. So it uses artificial neural network. But this artificial neural network is big, and it uses a hierarchical neural network. Usually it consists of one input layer, multiple hidden layers. And why I keep saying that this is big? Because it has multiple hidden layers. But for the traditional ANN, traditional artificial neural network, which has been used for more than 20 years, we usually have only one hidden layer. So that is a difference.
Yeah, I chaired a dissertation in Norway by a professor there called Koziwara, and she did a one-layer network in ANN.
Yeah, that is called traditional ANN. We have multiple. The reason why we need multiple one is that we need to extract more and more complex features from the data. So that is why we need so many hidden layers. Because these nodes are where the complex computation takes place. And we have have an output layer. So this is our outcome of classification. Let's use a very simple example to illustrate this. Let's say we want to identify a human space. So first of all, I will provide a large size example of human images to the deep neural network. And the first hidden layer will identify most basic elements of those images, which are pixels. And then as the layer goes further, it can identify more abstract features, which are edges, consists of those pixels. And then followed with another layer, hidden layer, and identify the object parts like the mouth, nose, ears. And then you can identify some initial object models. And finally, we can identify the face of an individual. So that is the way how our neural network identify highly abstract features from layer by layer. And the way we try to use this neural network to identify the text is the same, because we can start from the words, which is more basic, and then when the layers go further, we can identify more and more attributes, like the total idea of the entire paragraph or even the entire document. And our outcome is not a human space. Our outcome is the sentiment, like the positive, negative. So as the layer goes further, we can extract more and more complex features. So in this research, we attempt to answer 3 questions. First, if we add some sentiment features into our analysis, does it help?
Can you explain to them what sentiment features are?
We have 2 groups. One is for the overall sentiment, positive or negative. And the other group is the emotion. We have emotion of joy, emotion of anger, emotion of disgust. But in this paper, we just use the emotion of joy.
But explain to them how they are derived, because I think that's what the deep learning part is, correct?
Yeah, this can be derived because of they have a huge sample of text. They are from the English website, from English newspaper. And then they can identify when different words combined together. They can identify the overall sentiment of those words and the phrase and the sentences. So this is available just because they have a large sample size. But for some traditional like backwards approach, they use library, use a word list, which consists of the words, like positive words, negative words. They use the intent other financial reporting, footnotes, and we will discuss them later. So we want to see if we can add some information to help us identify the financial events. And if they do, are they effective only for the fraud detection, or they can still be effective for the error detection, because those 2 are different concepts. And the third question is we try to see how effective this approach will be by comparing with the most frequently used text mining approach. So here are the comparison table between the deep learning approach and backward approach. So this approach is try to understand the meaning of the text, because it learns from huge size of things. And the backward approach try to calculate the frequency of a specific word, like a positive word. What is the percentage of positive words within the entire document? And they base on a backward, a word list library. So in this backward approach, we try to, what we are using is a Lauren and McDonald's word list. They have 2 word lists, positive word list and negative word list. And we try to calculate the sentiment score, sentiment TN stands for text mining. And this equals the positive For the deep learning approach, we have two scores. One is the overall sentiment, range from -1 to 1.
The word list that you use, is that like specifically designed for business use, or is it a general word list?
Designed for 10K.
Oh, okay.
And it has been used for many, many studies.
Yeah, and if you remember, Yui and Kevin have a paper looking at comments of the SEC, comment letters of the SEC, and extracting, and they use the Logan and McDonald dictionary, and then they try to perfect the dictionary by doing some modifications, extracting words that are never used, and et cetera, et cetera.
So basically, you can form your own word list. For example, for that word approach, you want to look at news articles, and then you can like look for 100 news articles and search for some risky items, and so you can form your own word list. So this is the flexibility of the back of forth approach. But for the deep learning, we are not developing our own neural network because we do not own such large size of data. So we borrow the model developed by IBM Watson. And we use a tool called Alchemy API, can link us to a web service to call their model. And once we input our data, either a text data or just a URL website, we can come up with the score.
So you mentioned that you can enter your own words in this approach, correct?
You mean that words?
Yeah, so that's different from the model approach?
Different, totally different.
Okay, so in this approach, does it also like learn from words around the words you're loading words into a dictionary in this
You
deep
mean for
learning
the deep
approach?
learning one?
Yeah.
No, I didn't use any dictionary.
So what does the model use? How does it know what sentiment to assign?
The model, they have their, this one, they actually developed a deep learning model like this. And what they are using for the input layer is more than hundreds of billions of English. Like English newspaper articles and some other context with a wide range of topics, including finance-specific topics. So by using such a large input training data, they already developed well-defined neural network can identify the sentiment score and like the positive score and negative score and the emotion score.
But how does the neural network do that? I guess is my question. How does it assign a sentiment score to the information you're putting in?
They use complex computation within each node, which is not open to ours.
Oh, okay.
Yeah, because they disclose that it has no competitive advantages, right? But we know that we can demonstrate the effectiveness of the model by doing our research. That is why I'm doing this research.
Okay, hold on for a second. Neural networks are basically an algorithm, just like let's say, logic, probing, or whatever. Okay. It used to be, there is a classic article by Bell et al. That compared probing logic and neural network. Okay? And it's just an algorithm, that's all it is. What has changed with this whole thing is that we have now machines that compute very fast, and we have huge storage areas that you can use for creating your analytic domain. And so what they call artificial intelligence on this is just brute force using neural network in multi-layers. That's what it is. Now, what is the kind of problem that you can apply? This is a supervised learning problem. What does that mean? That you have an outcome and you have inputs to that outcome, which are the little balls that she has there. Okay. And what do? Let's say the problem is estimating bad debts by bank, bad debt assessment, KPMG is doing that. What do? You put all the evidence that you had categorized in the bonds, and the outcome, the output, is the loan defaulted or did not default. And then they have 100,000 of those. And then in a very simple way, with what Sophia already explained, that it's layer, they parameterize the hidden layer, and they have many little layers, with the best parameter they can put in there to, in those 10,000 events, come up with the outcome that they have. It's really brute force with an algorithm, the neural network algorithm. And so any problem that you have a lot of outcomes that you know what the outcome is, and cues for the outcome, you can throw this algorithm, set of algorithms to it, and get the best parameters that they can. So, classic example, the first item was medical. Medical, they have huge archive of skin cancer. So what do they have? The doctor diagnostic, this is skin cancer or not. And then they have they have pictures, they have x-rays, they have probes, whatever they have in there. So they go multi-layer on this thing and try until they have the best parameters they can. And then they don't need the outcome, they already have the parameterization. So Jamie goes to the doctor creates those diagnostic data, and the thing spits out, is this cancer or not? Depending on the nature of the problem, your prediction is better or worse. Interesting question is it better a prediction of the computer or of a doctor? And of course you, who are such a smart guy, is going to say, is this a good doctor or a bad doctor? But the next thing behind this is those outcomes were products of doctors. So some of them were good doctors, some of them were bad doctors. So you don't totally know that the outcome, the supervised learning outcome that you used was accurate. So obviously, if there is a good relationship between the evidence and the outcome diagnostic, and that diagnostic is reasonably good, the prediction model is going to be very good. If the relationship is tenuous, the prediction model is not going to be so good. And of course, the next question is a question about judgment. What is the question about judgment? Is how good is this judgment? Like, for example, individual judges are usually not as good as regression judges. Regressions, you predict with regression. I'll show my slides if you want one of these days. Okay. However, some experts are better than the regression judge. They had did you saw what was Moneyball, a film, baseball film? Okay, this guy comes in and uses regression to predict how good the baseball player is going to be. If you haven't seen it, it's actually worthwhile seeing. And I don't recommend a lot of films. The other one is this guy, Heister, who came out with a prediction using regression of the value of Bordeaux wines. It's a big business predicting the value of Bordeaux, because you buy the Bordeaux when they just come out, and then some of the Bordeaux are fishy. And what he used is weather and rain in the Bordeaux region and regression. And Mr. Parker, the most famous wine expert, says I would never have dinner in his house. But actually, in reality, he predicted better than Parker, the model, the regression model. And now there's a whole society of regression predictors of Y and et cetera, et cetera. But these two regression models were 5% better than human experts over years. So it's pretty proven that they predicted better than the average judge. But there is no proof that one particular judge is not better than the model, a real expert judge. But it also could be that that judge is just lucky. But this whole thing about judgment prediction is extremely important. I saw a documentary recently about what they are doing with skin cancer. And I wouldn't be surprised in 2 or 3 years, they have an app in your cell phone that tells you if you have cancer in the mole or not. Is it going to be better than an expert doctor? We don't. But it's going to be better than the regular doctor that predicts cancer, that determines cancer. Ben is looking at this. What is he saying there? And of course, what Sophia is trying to do is, and by the way, PwC is doing leases, I think. Deloitte is doing contracts. KPMG is doing estimates for bad debt in loans by banks. What are they doing? They are picking up huge, massive amount of PDF data that they have, the contracts, the bank loans data, scanning it, transforming from PDF, which is stupid, why are they keeping it in PDF anyway, transforming into text, and then applying this methodology, because they know on the bank loans how the thing came out. They might have a diagnostic on the lease or on the contract. And if you remember, Zauke Ian, now a PhD program, is working on contracts. We got 10 contracts from one of the big four, and we thought it was an interesting project to do this. But this was before the firms came out and kind of opened that they were doing these tools. Okay, now so we changed Ian's dissertation to the next stage. What do you do in auditing after you extract this information? And so that's where Ian is. So this is the context for this kind of thing. So when you hear artificial intelligence, the smart machines, it's not so smart, correct? It's brute force, but it's applied brute force incorporating human judgment. Now, there might be problems, and I don't know about this, but there might be problems whereby you can exactly know what the outcome is. In cancer, if you retroactively examine and you look at the molecular level, you know exactly what the outcome is. Okay, you know there is a normal growth of cells. Okay, and the nature of that abnormal growth of cells. But you are not going to go back and take skin samples of 10,000 people from the refrigerator and do that. So I don't think that they have that down pat. But you understand the value of this thing. And just think about applying this to 10,000 companies in CompuStack, seeing what, for example, happened with stock prices, and see if you can do a prediction. Okay, so do you have any doubts that there'll be a lot of research on this area with market data? And it's not only that, the complexity on that is what is the timing that you do? Because, you know, if you take the old crisp tapes, okay, you have a price every day, every minute, every second, that's the outcome. And how do you deal with the multiple layers and what information you get? And today, even much more complex, because today, let's say, the literature goes from 75 to 90% of all trades are automated trades. Okay, and it's not a composite of one algorithm of automated trade, it's a composite of many companies' algorithms, and within the companies they have different algorithms. So you can't think that there is one method of doing it. But they only get information quarterly and yearly. Now, if they take in consideration press utterances, there might be a comment about the firm any moment. But I don't know of too many algorithms that do that. Actually, I don't know any algorithm that do that, but I suspect there are some. Okay, but it's very interesting to think maybe you can come up with a price composite that is, and you could test that. You could see how well the predictions work retroactively with a holdout sample or with other methods. So this is going to be very big in the financial accounting area, and I'd be surprised if at this moment someone in Michigan or in Michigan would be a good place. Is not already working. Poor PhD students suffer because the faculty there have no idea about this line of research. Sorry.
To better answer JB's question, I want to add something. Because this is supervised learning, which means by using the training data, you know the outcome, you know the setting, is it positive or negative. So you actually, each layer is, each node is a linear combination of the input node. So you know the weight for each of these combination. Let's say the weight for the first node is like 0.3, 0.4, 0.6, but you just do it, at first time you do it randomly. We randomly assign the weight for each, how does each node for the input layer combine to form this node in the first layer. And then you can also randomly assign the weight for each of those nodes, layer by layer. And at the output layer, you know the outcome, and you compare your outcome with the actual outcome, so you know the error. So once you know the error, you try to adjust those weights. And once you're doing this process by millions of times, you can significantly decrease those errors. And the reason why we need those nodes is that besides this linear combination, within each node we have some non-linear super complex computation. So that's why by saying that we have much better computation ability today, we can come up with such a complex deep neural network because we have our cloud computing, we have a very huge size of storage. So we can, by trying this millions times, even billions of times, we can basically identify, we can fine-tune those weights. Because our goal is to try to come up with those weights, those coefficients. So the reason why we use their Watson's model is that they already defined their weights, and they're doing this continuously. So for example, we are doing this research. So I'm going to, so what I did is I input my data. So there are millions of people doing the same thing. So they have more and more data in their model. So their model becomes better and better by fine-tuning those weights. Okay. So
I have similar question about Jamie. So is it open to the public about the initial training data?
Initial training,
So-
there are too many initial training data.
So I can understand the input data is you mentioned the newspaper or articles, those things. But
They are English website.
yeah, but to training the model, we need to also the outcome of those news articles. So the outcome is initially to train those model, the human designated
Judgment. Yeah.
each of the news
Yeah.
articles.
For the initial training process, in order to have the outcome, in order to label them one
And
by
to
one.
manually
Yeah.
through the
Yeah.
what
I believe-
IBM's
yeah.
employers or
Yeah.
doing.
I believe they use human judgment in some software, but because we have more and more data day by day, so by using a model like this, it can make the machine do it on its own. So it's all learned by this machine.
Yeah, KPMG says that they are using some of their analysts to include human judgment in the process, but they won't tell me what they are doing. We actually had a call with them, and my impression was a guy explaining it. He's a guy called Macaulay Chan, didn't understand it very well. He had some technical guys working on it. But this is kind of extraction of semantics and you have to think that Amazon, IBM, Google, they are using this for the voice recognition. Okay, what are they doing? They're capturing millions of semantic utterances, recognizing what in voice, what they say, transforming into text, and then going against very large databases to understand what's being asked. So I think, and by the way, I'm inventing this. I haven't, neither Google nor Amazon talks about what they are doing very much, because this is trade secrets, correct? But from my research on this area and from reading a lot, it seems to me that they capture voice, they convert voice to text, because comparing voice to voice is very difficult. And at Bell Labs, we used to do this. There were projects on face recognition, there were projects with images in pictures, there were projects of voice, because remember, a telephone company does voice. First applications of voice recognition by operators, automatic operators, was at Bell Labs. Okay, so I think they convert from voice to text. They fix the text for spelling or for sounding, so the best approximation that they can. And then out of the text, they create utterances, meaning sentences, and they have a big, huge dictionary of sentences that they constantly classify. And they have humans responding questions. You say, what's the name of the mother of Donald Trump? If enough people ask that, they have a human, and they have these counting devices there, how many times a question is asked, and get to a certain level, they might need a human intervention. Okay, and that's, I think, the way they create the huge voice dictionaries. And when you play with Siri, is actually when you don't have internet access, what happened with Siri? She doesn't do anything, she dies, because she depends on those big dictionaries. And what the other interesting thing about this is that this is a very expensive process. Think about millions, if not tens of thousands or hundreds of thousands of computers sitting on the Amazon cloud or on the IBM cloud or on the Apple cloud, and they are there recognizing what's the name of the mother of Donald Trump. Trivial questions, correct? But why are they doing it? Are they that interested in the name of the mother of Donald Trump? So why are they doing it, Jimmy? Wake up.
Because they want to pull those questions together and be able to better predict those questions.
They want to have a dictionary of questions to be responded because the market wants them. Meaning, have you tried recently to ask some more intricate questions to Echo? Echo is the Amazon Echo, or to Siri? It's getting pretty good. And you like this, Ben. Siri didn't understand Brazilian Hungarian English, in my English, okay? It understands me pretty well. Yeah. And I think partially I can train Siri a little bit, and partially because it just got much better in recognizing. And one of the things that textual analysis does is, remember, a word doesn't mean anything. It's a word within context. Okay? And it can, gray and gray could be many different meanings, but within the sentence is reasonably clear to the human mind what that means. I want to say one thing about what Sophia said that I'm not totally convinced, is we call this new brain processes. I think they call neural networks, original neural networks, basically for marketing purposes. Okay, they have no idea how brains work. Okay, and now they have a little bit more idea on brains work, but still, the brain is a chemical thing just as well as a numerical thing. And there is high likelihood that the synapses do move, and that then will move, and the position of them also stores something. But people don't know exactly. By cutting mice and brains into microcosmal things, you don't really get the answers exactly, although neuroscience has advanced dramatically. But in your lifetimes, is there going to be a major change on how they think about this? This is back to what I said original, is brute force. Pure brute force, except that 20 years ago, you'd apply neural network and one layer. Now you have databases of 1 million utterances, and you have computers that can find them in 1/10 of a second or 1,000th of a second. And you have algorithms that adapt reasonably well on this. So it started with an algorithm, and the algorithm became CPU rich and became storage rich, and then other algorithms came in to help. Think about Uber, or no, better, think about Waze. Okay, Waze is a whole plethora of algorithms cooperating. At the same time, they are collecting data from millions of people, and it's very brute force. Have you thought about it? Have you collecting, let's say, 50,000 people traveling in this area here, figuring out what speed each one is going, putting it into a map, and then creating an algorithm for them to find the best way to navigate, and giving them an update every minute. I don't know what the algorithm for creating the new estimates, but etc. So it's a whole mix of data collection very rapidly, storage very rapidly, large library of events, in this case, the one that is called the utterances, and all of them together and that's really what intelligence is. Intelligence is pulling together different things. Maybe vision, maybe hearing, maybe none of the above, but a huge set of experience with words that is cumulative. And if you look at little children, how they learn, you notice that their ability to capture new concepts and capture utterance as word is far superior to any one of us. Until like 4 years of age, the mental processes are focusing on capturing. You say a word once to a 3-year-old, and they'll remember. Do you remember? If you hear one word in German once, do you remember it? No way. So the cognitive process adapt with age and with needs. And I think that's what progress, that's the algorithmic change, picking up algorithms to transfer from Hungarian, Brazilian to English, or from foreign language to regular language, or to interpret a wider set of words within a context. These algorithms that help each other. Okay, and I think that's what intelligence really is. Learning associated with these algorithms, storage, and large CPU power. Maybe adaptiveness.
CGU.
A little bit louder.
CGU instead of CPU. They're using
Yes.
CGU.
Yes. They found out that these chips, I made some money on that, or these chips that they use in games, the NVIDIA chips, which are the graphic processors are very good for this stuff. Okay, and so NVIDIA is selling a lot of chips.
So basically, deep learning is in our daily lives.
My question is the information that was put in to establish the deep learning algorithm from all the sources you were talking about, was it all like business sources or it was just related to all different types of
All
information?
different types of sources.
Okay.
Yeah, not exclusive for business. Okay, so deep learning actually is with us in our daily lives. Let's say self-driving car, the Siri, your cell phone, and when you go to the Amazon, it will give you a recommended goods for you based on your history of browse, based on the other customers' intention and their purchase history. So one more thing I want to emphasize here is that use the deep learning technology, we do not need any data pre-processing. Because if you want to use the backward approach, once you have a text document, if they are in HTML, you need to deal with the HTML text. You need to transfer the uppercase to lowercase. There's a lot of other punctuations, some signals, so very tedious and time-consuming. And also you need to calculate those percentage and do the calculation. So in the term of efficiency, I think deep learning is much better than backwards approach. But the one shortcoming for this is, as you mentioned, this is not exclusively designed for business text. It may include some legal text, some are just of general news articles. So that's why I want to test if it performs well for the auditing-related text.
Are there any other emotion scores except the joy? Why you choose
Joy, because I don't see any like anger emotion in our DNA. It's very rare, right? Disgust, but I can see the joy because if the management is confident with their financial statement, saying that their financial statement is free of material misstatement, it will express a joy emotion unconsciously. So,
pessimistic or overconfident rather than
there is no such emotion score and model provided by Watson. They are joy, they are anger, they are disgust, they are sad. So I just choose from them, and I did some pilot tests to see if they have some other emotions, but turns out the only individual emotion.
You know, an interesting question for you that just occurred to me is Sophia is basically forced to use the concepts that IBM extracted from those works. Okay, I wonder if there would be a different set of concepts that you would try to extract if you had the power of IBM out of those works. Is there an accounting set of concepts to be extracted? This could be a whole dissertation by itself, correct?
Yes.
But because now she's kind of force-feeding what she has, meaning if you have a hammer, you can't drill a hole. So is the tools that you have basically force her to do certain type of things. And because Sophia doesn't want to stay at Rutgers for the next 2 decades. So she has to do that. But it would be an interesting question if you can pick up different concepts out of maybe social media, maybe news pieces, maybe words in financial statements, maybe internal communications on emails in a firm, maybe just events in the stock market. Interesting question.
Maybe in my next.
You have a lifetime to do this.
Yeah.
For me, it's too late. Ben has a question.
Sophia, usually how many initial data do we need to train the model?
For the learning,
Yeah.
they have
Usually-
usually for them they use hundreds of billions. But
Yeah,
but if you want to train your own model,
Yeah.
Depends on the technique and the parameter you are using. It's not a very high requirement for you to use a huge sample. You can start from like a 100,000 or 100.
On that.
Okay,
Yeah.
so let me say something. Andre, if you remember, can you send them the last editorial that I did with Hussein and this young lady here? Because there we had this argument,
Yeah,
correct?
yeah,
Professor Kogan and me have been arguing about this big time. Because Kogan says if you don't have $1 billion, it doesn't work. And remember, I asked you to look it up the literature,
Yeah.
and you did find that that much smaller sample might be likely.
Yeah.
It's a question of if you have a very big sample, is more exact what you estimate. If you have a smaller sample, but that's just very gross argument. It's possible if the sample is reasonably coherent, you need much less to train, and if they're all over the map, you need more to train. I don't know, this is just speculation.
Depends on two things. One thing is the quality of your sample. If this sample is representative enough or not. The other thing is depends on the technique, depends on the parameter you want to use. Because when you are trying to train those models, there are a lot of parameters you need to adjust and you need to try. So there are also some techniques there to help you reduce your sample size, but still get very good results.
So last week, on Thursday, we had the SEC. Did you guys hear about this? The PCOB, yes. And there are 7 people of theirs, and we showed pretty much the sample of our work. And they were a little bit kind of blazed eyes with this and with blockchain. The other ones they understood better, but they were very interested, weren't they? Yeah, they are very interested because they read the newspaper just as you guys do and hear about AI. And I think I even made the same comment that talk AI, but this is really an algorithm. It's not really intelligent. Go ahead. Sorry.
It's okay. Good to discuss. Okay, so what we have is we analyzed more than 1,300 consultants and DNAs of clinical findings from 2006 to 2015, and we use those two approaches independently. So for the deep learning approach, we have our outcome sentiment score, DL stands for deep learning, and the joy score. The joy score measures how confident the model thinks this document is joyful or not. And for the backwards approach, we use sentiment TM because we do not have any predefined word list for emotion. So we only have, this is what we have, all we have. But for the misstatement samples, we use the financial restatement announcement. And then we found that only more than 300 of them are misstatements. So we are facing severe data imbalance issue. And in order to tackle this issue, for the training data, we use random oversampling, which means we increase the sample size of those financial misstatements. And then we use balance the training data to get our model, and then we use unbalanced testing data to test our model. And here is the initial proposed structure of our model. So basically because remember we mentioned that we want to see if this is only effective for the fraud or it's also effective for the error detection. So we are doing 3 tests. So the first test is that for panel A, we are using those 2 techniques, extracting sentiment score to predict financial misreporting, which includes both frauds and errors. In the second task, we focus on the fraud. And the third task, we focus on the errors. And then for each of those tasks, we have 3 models. The baseline model, they only use the predictor of financial misreporting provided by prior literature. And there are 35 of them. And model 1 used the backwards-based sentiment. Model 2 used the deep learning-based sentiment and the joy score. And the other control variable, they are all the same. So after we propose those models, we use the algorithm, chi-square, adjusted, interaction detection algorithm. This is a decision tree algorithm. Someone may ask me, why don't you use deep learning algorithm here to do the classification? My answer is because once we have their scores, they're all data, numerical data. So because deep learning, they are very effectively for the semi-structured or unstructured data, like the text. Text is the semi-structured, like the image, like the speech, they are all unstructured data. But what we have now, they are all structured data. So we just use a regular machine learning algorithm, a decision tree, a tree decision tree to do this. And then it turns out that for all of those tasks and for the two models, the sentiment features are all identified as one of the top 10 important predictors. For example, for the panel A, which is try to predict financial misreporting, the sentiment score of the text mining approach, they are identified as the second most important predictors. And the model 2, the joy score, is also identified as important predictors. But actually, the sentiment score for those, they are also in this list, but they have the same score, 0.03. So I didn't list it here. But actually, those slides just want to show you that the sentiment score, they are identified as important predictors for all of those models. So here is the result of the classification for the testing data. Remember here, the testing data, they are unbalanced. They are close to our real-life data. So let's just first focus on the fraud detection task. So this is our baseline model. This is our text mining model. This is our different model. We can see the overall accuracy increased. And this ratio, the AUC ratio, the area under the COV curve, this provides a measure of the overall performance of each model. So you can see there is improvement by using the deep learning approach. And the type 1 error rate also decreased, but the type 2 error rate a little bit increased. But remember, the actually financial frauds are very small size, only 300. So even though the percentage is relatively high, but the actual absolute number is not very high, just like 10 or 8. So overall speaking, we can see in terms of fraud detection, the deep learning approach performs better than was approach and better than our baseline model. Let's see the error prediction part. Let's say we see some improvements for the deep learning, but those improvements is not very significant. And the overall AUC measure also do not show much improvement like what we did for the fraud detection. So because of those facts, we didn't see similar change for our misstatement prediction. So we can answer our research question now. Yes, the sentiment features, they do add some information for financial misreporting detection, but it's only for the fraud detection, not for the errors and the misreporting. And by comparing those two models, we can demonstrate the effectiveness and the efficiency of our model. And considering those, the effectiveness and efficiency, we believe this technique is promising because it can kind of save your time by just do not need any data processing process. And if in the future we can use our training data consists of exclusively finance-specific topics, we expect the predicted performance will be much better. This is our future work. We try to increase the sample of our financial risk report and decrease the false positives. And here are two more deep learning applications which are also in my presentation. want to just try to examine the relationship between the internal control material weakness and the sentiment features of the conference call. And so we try to demonstrate the sentiment features has incremental informativeness for those relationship in order to predict the likelihood of internal control material weakness. So here are the initial results. So if we look at these two columns, we can tell that the joy score here is significant because those are baseline model. It does not include any sentiment score. So we can see here this is significant, but the overall sentiment is not significant. And we can see the R score increase. But we want to see, even though we observe an improvement, we want to examine whether those improvement is significant. So we did another test. We did a likelihood test. And when we look at those p-value, which is significant, we can tell that the improvement by adding those sentiment score are significant. And the group B, they look very similar with the group A. The only difference is that we include the growth variable here, which is 3-year average sales growth. And because this is a 3-year average, so it significantly decreased our sample size. So our sample size decreased to more than 700. But we observed similar results in group B. So the initial results support our hypothesis, which is we think the sentiment score is positively related to the likelihood of the IC and W.
Do you use contemporaneous period data or lifelong period? Because it's more likely
Can you say again?
to use the data of the same period or you just lifelong period of the material, internal control material. Because it could be that they have internal control material, so they are more likely to have
No, it's
positive.
1 year before.
Yeah.
It's
So
1
it's
year
not contemporaneous, it's 1 year.
So I mean, if last year they have a positive, they are less likely to have control.
weakness.
Yeah, but I think because last year they have control,
So this year they.
She thinks you should use contemporaneously. Is that correct?
You
no,
prefer to
just reverse that.
You mean if the first year they have internal control weakness, then this year in the conference call they have more negative?
Yeah.
I can try to test that.
Because
Maybe I can use a control variable in this column.
You mean if you have repeating weaknesses, like year over year?
have one
If you have repeating weaknesses?
Repeating.
Yeah, yeah. No, if, even if they do not have a period, but they just have internal control, so that would like affect.
If they have internal control weakness, it will be released in their management report of the effectiveness of internal control.
Yeah.
Yes, but what I'm doing here is the internal control weakness, which is not disclosed in their management report. Which
It's a prediction.
Yeah, which means it's discovered by the auditor. The management does not want to disclose that, so they will not try to express in a negative way. But the joy score may be captured unconsciously. Because they know that we have some problem in our internal control, but they do not want other people to know. So the overall sentiment score is not significant. But unconsciously, they are less joyful when they talk about something like that. So you capture that. So the internal control weakness is only discovered by the auditor, not disclosed by the management. I just exclude those samples.
Would you explain one more time? I can understand to adding the joy variable, but I cannot understand why did you add the growth variable.
Growth variable is sales growth. Is
for-
it's provided by quite literature. They usually use that. But if I just use that, it will significantly decrease my sample size. So I did those two. So my main test is for those which does not include that variable. But I also did another test which was fewer samples. Okay?
That's a problem with this whole area of research. Have also worked in a couple, is that the problem of variance, meaning fraud cases and etc., is very small on the sample, so that's the balancing problem, etc. And the other thing is, this is just hypothetical, but is discussable. The other problem here is most likely there are many non-reported frauds, with false negatives in the financial statement. Maybe one account is materially wrong and etc. And so finish out that your sample is small and corrupted. So that makes this so difficult to research. Okay, if you had a perfect world where you could go back and examine the past years of every company to see if they had fraud, or more likely wrong statements, then of course you could do a lot of things. But at this moment, all this whole area of research, what Keqing and Schwann and Yunus are doing, have the same problem. Is a very small sample of positives, and you know that there are a lot of, you don't know, but you pretty much think that there are a lot of false negatives. And we haven't come up with a methodology, and it's up to you to figure out a way to resolve this. Very difficult. What Keqing is doing, and Schwann, is they are creating false positive. They're creating artificial positive. They're simulating errors. And this is done in the literature in other places. And their method is doing very well. I'm very happy with what they are doing, what Yunus are doing. And KPMG is very happy with it too. So we think we have an interesting finding. But this is the problem with this whole area. And this is the first one I see, and she veteran for publication, because this is a pretty obvious area that some people will be working on.
But anyway, very good point.
That's very good.
Sophia. So the growth rate is the most effective variable until the literature find until now, but you overbid the most effective variable by adding the Joey variable. Oh, okay.
And you said this, what just happened, is happening here, what should be happening in our assembly. You guys asking questions.
Yeah.
And no shyness here. Ask.
I'm very glad.
We'll tell Professor Alice to keep quiet for 10 minutes. And you can ask questions.
So glad you keep asking questions, because I didn't expect that. When I was doing similar presentations, I usually do not receive so many questions and good points. Thank you so much. Okay, the last one is I tried to use the social media message. And the difference between the social media message with the previous two text document is that social media message is short. So it's very hard to just to use deep learning to analyze the message, the sentiment. So I'm still using deep learning, but I use a different tool. It's called Watson Analytics. So it's designed specifically for the social media, for the tweets. So I'm using the sentiment, and I'm using the count of tweets. I'm using the maximum number of the retweet, the average number of retweet, and number of followers, and some more information about followers. So there are a whole bunch of information in the tweets. And I'm trying to use this to predict the financial pricing, because this is the outcome of financial planning. So I'm trying to answer the question, and the author, they do consider they do read the social media before they plan on the audit of this client. So this just started, and I just collected the content information on social media of the tweets. Contains 4,852 from years, which includes involves three. I'm trying to say.
Do we have President Trump's tweets here?
Maybe. I will check it out.
I bet a lot of his tweets are from.
Yeah, he likes doing the this. So it involves a use and of trees, but I did not use them directly. I just use the content data. So because it only can provide us with 2 years, recent 2 years data. So it's I'm still working on that. So I plan to increase the sample size after 2016. And so I will try to use two methods. First method, I will try to use a statistical regression model to do a linear regression with the relationship. And then I will try to use machine learning algorithms to do a prediction task. And
I think Andrew has one project related to tweets.
Oh, yeah, that was my proposal for you.
Yeah, in the accounting class. Then we had like how do you distinguish tweets like
The-
it's
the
actually
tone.
not relative to
Or like sarcastic tweets, right? Or if I'm neutral, how do you distinguish?
well, we have positive, we have neutral, we have negative, we have ambiguous.
yeah, like so let's tag the company name.
The company name or the ticker, the symbol, ticker symbol.
For one example, I just like I want to drink Coke today, but actually I didn't mean to mention like I'm positive about this company or not, but it's just a neutral statement.
Neutral statement is another route. So we have the count of neutral statement, we have a count of positive statement, we have a count of negative, we have a count of ambiguous. They're all one of my variables.
So
Still use.
will that be classified as neutral because I like Coke? Maybe the like will be classified as positive, but
It could be. Because again, the outcome I use is from IBM Watson Analytics. So another question?
When you're saying you're using different deep learning algorithms, you're saying like the coefficients that you mentioned before are different. Does it also mean like you have a different number of layers? Because
Different what?
Diff-
Number of layers.
Yeah.
Yes.
Okay.
When you're using two different models, you may have different number of layers. Everything will be different.
But isn't that? I feel like that's the most difficult part of writing, or because if you're the researcher and you're actually developing a deep learning algorithm, then you have to you're the one that has to specify what the layers are in the first place, right? And is that hard?
It's time consuming. You usually you start with three hidden layer, and then you keep increasing the number of layers, and you keep adjusting the weight and other parameters, and until you have your best result. So it's super time consuming, not very easy.
And CPU consuming. And if you are doing this with your laptop, it will take the next decade to get it.
Yeah. But nowadays you can use CPU for 7 minutes.
And she's forced basically to stay with the algorithms that she did,
Without
with the things she had. Interesting, one comment for you is what the PCB guys asked last week. They asked the following: now that if you know the utterances that joy that affect the markets or affect an audit, would the preparers change the words they use? Remember they asked that? And I talked about feed-forward effects, and that there is literature on that. What's a feed-forward effect is that certain research findings might create changes in behavior in practice. Only if they are relevant. If they're irrelevant, they are not going to be changed. And there is no question that if you find some of these effects consistently and is spread among practice, they will change behavior. But of course, what you are doing here is like you are doing with Google and whatever. You keep changing your vocabularies. You keep changing your algorithms, adapting to what you're finding. What's going to happen, God knows. Jamie, you have a question?
Yeah, but also the feed-forward effect will be mitigated a little bit because one of the factors she was using was subconscious joy. So even if you try to, there'll be elements of your pattern of speech that won't line up with subconscious
I have a very personal reaction to this whole thing. I don't like very much the whole, this is the only thing we can do, so it's okay to do it. But the fact that you examine the personal sentiments, a document written by a committee with lawyers and public relation people, is very different than if Sophia wrote a letter angry about something or happy about something. The moment the lawyers see that, they're going to change the wording, they're going to think about old litigation, and et cetera, et cetera. So when Kevin does this work or Sophia does this work, I say, good, because that's all what you can do. But in reality, there's a layer between a person, a lawyer, a public relation person, the CEO, and the CEO is the person, or the CEO doesn't write anything. It's his CFO who writes it, and it's the staff of the CFO who writes it. Okay? And so these are remote effects, very remote effects. But that's all what we have. And it's better than nothing, I guess. Meaning she's finding effects. So it's better, certainly a new way to think about it.
I just had a question for you because I got the same question a lot for my proposal in class. How are you extracting the tweets? Are you extracting it by hashtag or at Coca-Cola, for example?
With a hashtag. Next to the hashtag is Coca-Cola.
Okay, because depending on how you do it, you're probably not going to find a lot of tweets for companies that don't have a Twitter account, right? So I think the hashtag is probably better.
Yeah. Hashtag.
And that's something we could look at a little bit more. There is a text mining method of getting the raw tweets and do a classification. An interesting paper, compare if you classify or not classify. Also, it's a financial accounting paper. So the sort of, meaning people are going to use tweets in research. They are using it now, okay, in financial accounting research. The question is, how can you improve it? So guys, you want a 5 minutes break? And who is that? Andrea, what's the next paper here?
It's big data's complementary audit evidence.
And who is doing it? You're doing, get yourself set up while we're doing that. So he doesn't get to go to the bathroom.
By the way, thank you
How
so
are you
much
doing?
for your comments and questions.
You like deep learning? Have you had it in other class? No. So going back to Professor Sophia, she'll give you the for me. She knows more about deep learning than anyone else. That's what they're talking about. And you know, by the way, blockchain is a big business. The entry
And also I use the dollar sign. If you use dollar sign, it means it's a stock. Stock.
All like stocks, right?
Yeah. I tried combinations.
Whatever you're doing, like the audit fees, for example, they vary by S&P 500 versus
Yeah, I add something.
you would expect, I guess, if it's a listed entity, that it will be higher depending on what the sentiment is saying, right?
I haven't gotten the result yet. I will see. Oh, just from the
Alright, I have this class that I forgot what it was, but it was I wanted to see the sentiment mediates the relationship of merger transaction.
Yeah, because the tweet does not allow you to obtain so many
Yeah.
tweets. So what I'm doing here is I'm using the metadata of the tweet. I mean the content data, not the tweet itself. Total count tweet is provided by analytics. Yeah, and some information about the user of it.
Yeah. Oh, that's good.
It's already there.
Because I tried to do that R algorithms, Python, and I forget and I talk about so many.
It's the same. Look very similar to TalkWalk.
Oh, really?
Almost the same product.
That'll be interesting.
But it's super time consuming. Although I
That's why I haven't done any.
think about it before you do
Yeah, I know. Yeah.
Usually, if we add additional variable, the prediction quality is increased.
Yes, but that's why I use long likelihood test to test if the increase is significant or not.
Yeah, so
Yeah.
no, I mean not the growth rate, but compared to the baseline and the text mining model, the Rutgers back of language is the method.
Oh,
So these
it's
two,
two different things. If you are using a statistical analysis by adding one or two more variables, it will increase your odds score. So that's why I'm using a long likelihood test to test if this increase is significant or not. But when you are using a machine learning algorithm, by adding two or more variables doesn't necessarily make better results. Okay? Talk to me.
I hope you learned something. So as a preface, this is one of the 6 articles on a special issue of, or a special part of Horizons dealing with big data. And we are thinking, we have talked to Horizons that they're interested on creating one more, not mainly on big data, mainly on algorithms, mainly on analytics. So that'll be a follow-up on this whole set.
Yeah, it's also very short paper, 7 pages. And this paper is all
So we judge papers on number of words.
Just say I didn't spend a lot of time reading it. It's finished. So the purpose of this paper is to evaluate the applicability of big data and provide cost-benefit analysis for sufficiency, reliability, and the relevance considerations. So audit evidence is the entire set of information collected and evaluated by auditors when deciding whether a firm's financial statements are stated in accordance with generally accepted accounting principles. Auditors are becoming more holistic in their audit risk assessments, examining evidence available from various sources in order to decrease the probability of material misstatement and audit failure. And in the big data era, techniques have improved to the predictive power of data analytics routines. Thus, decisions will be more data-driven than experiments. And the most dominating characteristic of big data is its massive size, together with some other characteristics such as velocity, variety, and veracity. So variety is about the different types of data sources, such as global positioning systems like GPS, measures of logs, video streams, website traffic, audio files, etc. And the veracity is about how to eliminate noise and get truthful information from big data. And to do that, which requires very sophisticated text mining techniques to do that, like visualization, predictive modeling, association, and clustering. So according to professional standards, audit evidence needs to be sufficient or appropriate. And sufficiency refers to reliable and relevant, making the collected evidence more persuasive. And big data contributes to sufficiency requirement because of its volume and variety of data provided on a real-time basis. And for appropriateness concerns, on the one hand, big data can be quite reliable because it is often externally generated and acquired by auditors directly. And on the other hand, the noise in big data may cause an overload of false positives, which might lead to low predictability power. So the evidentiary requirements provide framework to assess the noise, to assess the usefulness of big data as audit evidence. So in terms of sufficiency considerations, the scope and quality of collected audit evidence are affected by technology, such as whether the evidence is in some kind of form, like computerized form, and it's also affected by cost-benefit constraints and social interactions with clients. So there's an example. So like the relevant external big data could be a complement for the client's internal information that is not readily available to use. For example, while auditing a manufacturing company, auditors may request the management sales forecast because they could be useful to understand production line or something like that, like inventory levels. And the auditors could also use some text document to analyze from the big data from newspapers, articles, discussion forums to understand the incentive and sales trends of the clients. So big data can also support the traditional audit evidence is deficient, as might be true in the case of fraud. And for example, evaluating like emails can be very useful in identifying the person's motivation and probably some rationalization, like how to perform some things like that. So the major sufficiency-related benefit is the information abundance provided by different forms of data in massive quantities. And the primary cost of data processing in the data processing effort necessary to reach a certain audit thresholds. But nowadays, some advanced data analytics are available, and these analytical tools are more powerful for large data sets, and it's more friendly to understand. So as for reliability concerns, certain types of big data can help assess the reliability of traditional audit evidence. And traditional auditing requires that documents are inspected manually to verify business transactions. However, in the big data environment, auditors can use text analysis such as clustering analysis to parse and summarize the documents. And this approach is more efficient and more revealing than the traditional auditing. Also, big data from external sources like news articles, analytic reports, government reports could offer independent benchmarks to assess both internal and external trends of financial accounts. Because employing non-financial information as part of the analytical procedures can provide an independent benchmark for the evaluating financial statements. And the major source of big data reliability is that it is extremely difficult to tamper with the data given their vast size. Especially.
Let me say something about that. I wrote that thing. And there is a qualifier to this. This is a little bit like picking up data from corporate data stores. When you are picking up the data, you can filter. That's tampering. Okay, so the auditor has to look, or the auditor or IT or whoever has to look at the way the data is being extracted to make sure that it's an unambiguous, unbiased source of data. You were just asking that Sophia, how do you treating the treated uteruses, correct? What she's doing there has a bias. What is the bias? Is the company is not frequently traded, okay? Typically people won't go into tagging and et cetera, there won't be. So there is capturing on the bias. And so that's something that needs to be taught. And I always say this, that external data with well-known provenance is much freer from bias than corporate data, except for this particular thing. The corporate data has the same kind of thing that has to be, when at the extraction process, you have to be very sure that the extraction is unbiased. But in corporate data, the generation of the data can be highly biased. For example, you don't record transactions by Selena, okay? So it never gets into the records. However you extract it, it's still not going to be there. However, in big data, you can really not control for what gets into the big data environment, not acceptable because there is no acceptable. Do you understand what the difference here is? Okay, let me repeat because I can see her like this, she's not quite sure. What I'm saying is that the collection of data in big data is totally out of your domain, okay? Or is somewhat out of domain. You can always say thumbs plus for your own products or something like that. That's in that part of the environment. But you know, it's very distributed. What was she had 235 million uteruses or thousand, I don't even remember the dimension. Big number. Okay, that's very difficult to cope. The way you extract it, you can be selective. Okay, but the provenance, if the provenance is good and the extraction is okay, you have a much less biased source than an internal company data where you, as a player of the game, can do some control.
So this paper also presented an example of bias about Twitter, that is, the users of the Twitter might not represent the entire customer population that might cause bias on this problem. So this is about relevance consideration. Auditors are required to understand the broad economic environment in which their clients operate and analyze their clients' business risk accordingly. The content of news articles is likely to indicate the firm's future earnings and stock price prospects, and also professional standards also require that auditors evaluate risk related to economic weaknesses and fraud statements. So management's disclosures would be particularly useful in this case. The overly optimistic press releases or annual report messages are risk factors related to potential fraud. And similarly, executive use of the deceptive language in conference calls can also help to identify financial misstatements. Therefore, text analysis of management disclosures is relevant to the assessing the risk of management fraud. And the nature of e-commerce presents a unique opportunity to use big data-based auditing techniques. And this indicates that auditors will increasingly be facing clients who have very different types of business processes, prompting the need for collecting different forms of auditing evidence. For example, auditors auditors can compare the client's website traffic data to that of competitors with similar customers over the same time period. And any inconsistency should be identified for special attention. And even when the client's own sales report shows no problem. So the major cost of that evidence generated from big data mainly suggests association, not causation. And it is related to the deceptive behavior of CEOs and CFOs, thereby being associated with financial misstatement. So audit evidence can be characterized into 3 levels: financial statement, individual account, and audit objective. So audit efficiency could be significantly improved if audit evidence at the financial statement level is complemented by big data related to misstatement probability, because auditors tend to collect excessive evidence at detailed levels without analyzing the evidence at financial statement level first. Also, tax analysis of company disclosures and the conference call transcripts helps auditors estimate the misstatement probability. And on the individual account and audit objective levels, big data analytics could reduce false positives and identify more important anomalies for further investigation. There are also some critical challenges about using big data in audit process. The first one is the concern about the integration with traditional audit evidence. So integration involves identifying and establishing important relationships among information from several sources. And in most cases, auditors will obtain both quantitative and quantitative, or like objective and subjective information. And this is a critical factor in determining the quantity of an audit opinion. And big data is often unstructured and specifically may not have the structure needed by relational databases to uniquely identify transactions, customers, or producers. For example, auditors may use GPS location data to verify certain transactions. However, like matching big data information such as GPS data to the traditional accounting records can be very difficult. And because of the size and the unstructured nature of big data, auditors must have sophisticated techniques to summarize the information, and such as like data mining and statistical analysis techniques studied in previous literature. And data sources may be correlated, such as social media and third-party news articles, so that the incremental value of using big data might be very low, and the evidence obtained from multiple sources may be less than the sum of the whole evidence from each part. And also it might not be easy to adhere to the traditional systems for weighting evidence from big data. And big data commonly does not offer precise information. And sometimes the data from sources, such as news articles, may be affected by biases, like just mentioned in the case of Twitter. So auditors should weight big data evidence under a framework of evidentiary requirements. That is, auditors must estimate the total amount of audit evidence for each specific audit objective, combined with sufficiency, reliability, and relevance requirements. So in order to reduce detection risk, more weight should be given to audit evidence generated by big data if they provide more disconfirming evidence. Another challenge about big data is information transfer. So auditors who specialize in certain industries are often considered to produce high quality audit because of the both the in-depth knowledge and greater economics of scale. So the general knowledge and expertise obtained through a client engagement is transferable to other engagements. For example, when the external auditors know some general customers' responses to a new iPad of an Apple company, this general knowledge can be used as audit evidence for not only Apple company but also other related peer groups companies such as Google or Nokia. And clients who fear information transfer to competitors may actually avoid hiring specialized auditors. And this issue can be intensified when external auditors endeavor to assess a wider scope of internal data resources because there are higher costs in collecting and analyzing big data. The economics of scale may grow. Hence, specialized audit firms may utilize more big data as audit evidence than other firms do, and leading to a higher barrier that prevents competitors from entering specialized industries. And to solve the information transfer issue, auditors should formally contract with clients with regard to the usage of clients' internal data. And in general, auditors should only use highly synthesized information from big data for other auditing tasks and limit the access to the original unprocessed data. So the last concern is about information privacy. So information privacy is described as the ability of the individual to control personal information about oneself is a significant challenge to utilize big data as audit evidence. So for example, internal emails could be used to detect fraudulent employee behavior. However, once external auditors have access to the employees' emails, employees may feel their information privacy is violated. So to alleviate these concerns, auditing firms should cooperate with their clients and inform the employees in advance that any work-related data sources could be used for audit purposes. And also, the audit firms should communicate with employees that work-related data would be used for a particular audit chapter's audit. So this paper provides us with some further research directions, like developing standardized data analytics to retrieve relevant auditing evidence from big data more efficiently, and design data bridge techniques to integrate big data with traditional audit evidence, and identifying relevant big data sources for firms in different industries for auditing purposes. And the last one is to update auditing standards to regulate information transfer and privacy issues. So that's basically about this.
So what do you guys think?
So for auditors, they have to understand how to deal with the big data. That's something that needed for card auditors.
Does accountants need to deal with big data?
Yeah.
You guys are my token accountants here, so why? Maybe. Go ahead.
For one thing, you need a lot of data to make. If you make estimates in your accounting, then it's better to have more data to make better predictions.
So for financial measurement and management, particularly forecasting, is that what you said?
Yeah. Yeah, like impairment testing.
Okay, good. Yeah, I agree. Meaning if part of corporate processes become forecasting markets, it's difficult to conceive that in the corporate processes are not going to accumulate some relevant big data information. Internet of Things, social media, at least what I'm thinking. If the company is very public relation related, newspaper. Public relation, I mean companies that whose business is sensitive of what there is a lot of, let's say, risk on the business. Now, how about accounting research? I'll go to you in a second. I'm sure you can say something here. I want my token accountants to say something. Didn't I say earlier that this kind of deep learning is going to be very big in the accounting literature? Is big data big in the accounting literature? Yes, no, maybe. Yeah. Well, remember, Ball and Brown, market value. It's a function of all-based financial variables. The R squares here are 0.3, 0.5, 0.05. Okay? So what did Baruch Lev says? That if you add non-financial variables, you can improve them. A couple of his PhD students actually did a lot of studies there. Are we missing something here? Exogenous variables, things in big data. Does social media affect the stock price? No? Yes. Does it, Selena?
To some extent.
Does it affect? Social media affect stock prices?
Yes.
I think so.
Yeah.
The limiting protection.
If you can get data of shipments from a third party, like Internet of Things, does that affect stock prices? Yeah, everyone is trying to make a buck out there. Anything that's influenced, think what they say about drugs about your company, does it affect your stock prices? So are there people in your company looking at that? She works for a big farm. Actually, I was sorry, I should have arranged a meeting with Hussein, not our Hussein that you met, the other Hussein, who is a head of our farm. He might be a good guy for me. Okay, so I don't need any more things. There are things out in the big data environment that could help you to explain market value. Is this an opportunity for research? So why do those guys go like this and you are all?
We're still thinking about.
Good, I like that.
Why do we need to forecast? This here is forecast the market value, right?
That's what Ball and Brown did. Did you read Ball and Brown?
But I remember the stock price is random walk, so we can't predict the stock price. So
Ball and Brown made an equation with income in one side, market value in the other, and says basically, if you look at income, you will understand significant changes in market value. That was Ball and Brown. And since then, what market research has been is adding variables on this. Correct?
Yeah.
And of course, the traditional market research basically said that things are not totally random and there are major aberrations on these markets. Okay, and a lot of the studies that come here and use this methodology, like the guy from Wharton, they were looking at factors that affect stock prices, valuations, methods. Yes, sir.
Professor, but how do you find those new technology like Amazon Echo or Series, or there are a bunch of new things coming out every day, and for me to understand or to apply the accounting research with big data, the first thing is to understand or to familiar with those.
I think the original thing is trying to put some of these exogenous variables in. Guys, that's not my area of research, so I'm just blabbing, okay? But I think that that's the first thing that's going to happen. People are going to take variables that will affect very much here and put some exogenous variables that might be there. Okay, that's the first thing going to happen. After that, maybe we go into what Ben is asking here, is segmented into different devices, different type of information, etc., etc. How do we do it? Don't ask me. You are going to invent this. Jamie, you had a question. I just yes, you did have a question.
What was my question then?
I don't know what it was, but
I don't remember.
you started asking a question, then I went to them, and then
No.
you forgot.
Yeah, I forgot.
Hey, I'm allowed to forget. You are too young to forget. Okay. Okay. Any other comments here? This paper is totally conceptual. It's very new. And actually, I was looking at him presenting, and I said, "Did I really write this?" I had forgotten this was a year ago or 6 months ago. And actually, I see the touch of Helen here, because I see a lot of Helen thoughts, kind of thing. Now, I'm going to give you some interesting thing that you guys will be interested in. Okay, my token accountants here. When I went out to the SEC to do the brown bag with Hussein, okay, we had a phone call with the CIRA, the people that are doing they call it Robocop, but it's basically a reassessment, trying to detect fraud in financial statements. And the thing that they wanted most to hear was about this. And actually, the guy who forced us to do this was Mike Willis, who is the guy who did XBRL, and he is the guy in there. And he said, talk to them about third party, talk to them about exogenous. I didn't use those words, he used about big data. Okay, and why? Meaning when people don't tell you something is information too. Okay, and I immediately interpreted why it is. First, they don't want to tell me anything. So they want me to go there and tell them all the analytics that we do, but they don't want to tell me because CIRA is proprietary. Okay? Why is the reason they don't want me to hear about CIRA?
Well, you could learn how it works and then go commit fraud.
Okay, I can go and commit fraud. That's unlikely. I might teach Mochi how to commit fraud. But no, that's unlikely. Mochi is my furry dog. Okay. That's unlikely. But they don't want someone to create a business that is a consultant to companies and quietly said, this is the filter that CIRA uses. And not to get caught by this, pay me $1,000 or $10,000 to run my model on your data. That's what they don't want. Okay, I don't think they think I will defraud them, but I think that's one thing they don't want. What is the second thing they don't want? Come on, guys, be brave. They don't. Go ahead.
The model is not so sophisticated.
That's right. They don't want to be look foolish. Okay, so it's some stupid professor at Rutgers University comes in and finds a better fraud prediction model than theirs. Okay, so they won't even tell me what data they use. Now, you don't have to be very smart to know what they're using. They're using XBRL data or computer star data or both. And they are using a couple of other sources, which I'm not totally sure, but they're public information and not big data. And so by asking me all about external data, they said they're interested in including that in their models. So
for, I still say for auditors, so for future, if they want to use big data, so they need to be trained first, right? Like the statistic, like how to program, like even some PhD work, like you said, the algorithm. So this threshold is very high for auditor to learn all of this. So for future, if there really are big data, so of course the current ability of auditor couldn't handle it. So how could they?
well, CIRA is an audit kind of effort, correct? What is CIRA? CIRA is basically using third-party data to detect anomalies on the report.
Yeah.
So that's kind of auditing, correct?
Yeah. But yeah, as you say, you want to forecast the fraud or detect the fraud. For the future, for auditors, how could they do the audit researchers do it? For a normal, regular auditor, they couldn't use this model or something because of what they are.
If you find that fraudsters use the word whale, the semantic word, the whale very often, okay, and then in your archive of tens of thousands of filings, time they use whale, it was fraud. There is a fit for the fact the moment you announce that and people discover, the experts, no one will use whale anymore. Yes or no? So that's very clear. But I think what she pointed out, which I think is true, is what is the corporate accounting system? That is not bookkeeping entities, okay?
Yeah.
It's the whole measurement system of the company, of which only gets audited in the financial side. So, because the incentives to defraud on the marketing side and etc. are very different, is a whole different domain. So only verification is in this kind of anachronistic rules of accounting and verification of those rules. But in the corporate management system, which is very important for the company that it's right, or you're not going to do very good business if your records are bad. That's really the accounting system of the firm, the measurement system of the firm. And there they are. The firms are collecting these things here. Okay, they might not be using the Bollinger model, but they are collecting exogenous information for their own operational purposes. Yes.
So I've been listening to a very good discussion from a practitioner's perspective. We do
I thought
use-
your PhD student, you're not practitioner. Joking.
I've been in the
She's
business.
a little odd.
I've been in the business for 25 years. And the way we bridge the gap is we collect data from all parts of the organization, not just the financial piece. I myself am IT and finance and operations because I have an engineering degree and I have a couple other degrees that go along with that, okay? But what we do today is when we build our risk model, we're taking data from all these other angles. And the approach that you have, one thing that I was going to mention to him on the presentation, the way an internal auditor looks at it is very different from the way an external looks at it, right? So there are two separate ones. On the issue of the privacy piece, you're bound by certain professional ethics. So if you're a CISA or a CIA, you have those things in place already that protects you. You also have to sign with the company in terms of privacy issues, right? So auditors will get information. Oftentimes what we say, just so that we're not put in a compromising position, is that you're going to get it and you get the information that's been scrubbed, right? So you have, it's encrypted and you get it. And you can go back and you can point it out to them. But most of the time, the other piece of it too, and I know I'm jumping around to a few different points, but the other thing too is we don't always just look for fraud, right? Because you have a group, you have a compliance team that's looking for fraud. You have a SOX team that's looking specifically at requirements for the SEC. And you have auditors, the internal auditors who we are, that are looking at it to say, okay, everybody else is looking at these things, but do you still have a gap in here, a control gap that you should be identifying? And that's where they bring in specialists like me, because they'll say, okay, you know what, we have all these teams looking at finance, we have somebody looking at compliance. Okay, Desiree, you come in now and tell us what you think, because now I'm connecting everything with IT as well as finance. And it's my job to say, okay, this data, either the data is not going in the right way, either we don't have the right controls on the IT side, or we don't have it on the finance, or maybe it's an operational thing.
Okay,
So we bring them together now.
This is a potpourri of issues that
we do bring it back
okay,
together.
the first thing is, I think you heard me talk about audit-like organizations. Okay, that's the survey we did of internal audit with Sripan and Sylvia. And we are talking about this morning, correct? And we surveyed 9 top internal audit departments at one of the big four's requests. And the thing that struck us most, maybe second most, was the fact that, as you said, some results, internal audit, fraud, et cetera, et cetera. And they do kind of similar things.
They do.
And the lawyers spit and chalk. The auditors, internal auditors in big firms have some IT audit with them, but surprisingly too few.
Yes.
Okay, we found something like 15% of the auditors are computer auditors. When I started teaching, I'm going to now reveal my age a little bit. IT audit at USC in '74. I said in 5 years there'll be no traditional auditors. Everyone is going to be an IT auditor. 40 years have passed. 40 years have passed, and still 10%, 15%. What do the non-IT auditors do? That was always my question. Now I have a new theory. My new theory is that tools have been very bad. And this is June's fault. She's the one that brought me to this theory. And we need to improve the apps in order that the non-IT auditors can do useful things. Okay? But anyway, what found in the survey is that many organizations do similar type of things. Now, when I was at AT&T, we were told that our emails were public. Public now, corporate possession means they could, and many companies now have monitoring devices to see what their employees are using their mail.
Yep.
Very common.
Also your IMs. And your phone.
Well, that they can control if you do it within the company with the company phone. Okay, but it's very difficult for them to monitor your IMs, your social media posting, and etc. if you're doing from home on your personal computer.
Right. But if you're talking to people, most of them have communicators within the company, and they track them.
Yeah. And back to what the accountant is doing is we are here. You saw my drawing. This is just for your benefit. This is a relational database, and the ERP is basically a whole set of apps around it, and very little piece of FI financial is actually what gets close to the public. And this is the only part that's really audited. except if there are other little systems here that affect the quality of them. But what actually is happening in the big data is starting to affect the quality of them. And what I'm saying in auditing, and we said on that article, is that there is going to be a whole set of new evidence which relationship with the reports might be a little bit tangential, but that set of data has one characteristic. It's very difficult to originally be intended. And if the extraction is monitored, is reliable data, although less directly connected. And when I talked to one of the Big Four, they asked me the following question, the research guys. Can we audit a firm without going to the firm, without looking at their data? And I guess social media, IoT, which is going to be very big, et cetera, et cetera, et cetera. I would love one of you to do your final project looking at the effect of IoT on the effect of IoT on auditing data. But IoT, et cetera, is going to create a whole stream of audit evidence. Meaning, if you can measure every truck that goes in and out from your company, and you can have the RFIDs of the product sitting inside of that truck, you can pick up a lot of the motion of equipment, of inventory out of your company. Okay, and that goes on and on progressively. And these things are created not for the auditor, they are created for running the business. And then you can use it for audit. But progressively there is going to be this layer of external information that you are going to sift, meaning choose a little piece of it because they are too big. That's going to help you to run your business. And as helping you to run your business is going to have effects on your financial statement. And you heard a little bit of this discussion prior, you didn't hear this discussion prior. So that's the scenario we are in. And I remember 20 years ago here at Rutgers, when the web was just created, I was talking about the web will be important for auditing and et cetera, et cetera. People looked at me and said, Thank you. I only read one of the proposals for project in this class, and I liked it. So let me read the other ones. I only got one today.
We got 4, I believe.
So where are the other ones?
I sent you.
Yeah, we have them.
You have them?
Yeah.
Okay, good. Let's do a little bit, we don't have a lot of time, but let's do a little bit more. What's the next paper?
The effect of social mismatch.
That's you, Selena? I was imagining of asking you to tell about your planning to do in the class, but we'll do it next time. One more thing while she's setting up. I hope you guys can make Tuesday the 28th for dinner in my place. Yeah.
Today or
28th. 28th. So I gave you a little bit of time to get to plan. Okay? Now who has cars here? Who has cars? You have a car? You have cars.
Oh, yeah.
Okay, so you can, Andrea will come, you have car, computer, so you guys can pool together. Okay? I'm organizing it at 7 o'clock, so my house you can't park in front of my house. At 7 you can start parking. So if you want to drive into the city, it will be very easy parking. Driving into the city at that time is a little bit challenging, but it's not horrendous. Remember, it's inbound, not outbound. Yes.
Is it public transport? Like, does the subway go by your house?
There is a subway by my house a block away. But maybe you can pool with one of these guys. Okay. There is a subway. I am in 62nd between Park and Lex. There is a corner of 63rd. There is a subway. Or you have the F line. There is 2 blocks the other way. Very easy. Professor Kogan is neurotic. He never drives into the city. So put down in your calendars,
Okay, sure.
28.
All right, so the paper I'm going to talk about today is the effect of the social mismatch between staff auditors and client management on the collection of audit evidence. This paper is by Bennett and Hatfield, 2013. It's actually published in the Accounting Review, I think. So the research question here is, are staff auditors influenced by the client manager's social characteristics in the audit evidence collection process? Why do we all think this is important? Because audit work is expensive and risky, so it would be good if we can mitigate some psychological biases to optimize the process and then reduce costs that might arise. Also, firms are concerned with auditors' reliance on electronic communication. There's been, as you can see, I listed a few researchers there, which this paper also deals with. And we also want to know how effective has standards and professional training been in curtailing these biases. So that also relates to what standard setters should do in their processes, if there's anything that they can change to mitigate, because this paper is about psychological biases, so deal with that. So the prior literature, a lot of it is from the background of this paper is from psychology. Psychology has shown that less experienced individuals are more likely to be inhibited in their interactions and behavior. Also show that avoiding and retreating is possible when faced with undesirable situations. And individuals have a limited ability to manage the outcome, so they respond when they do have the limited ability to manage the outcome. They respond with avoidance behavior. So also difficult social situations may lead to emotions such as anxiety, inhibition, or embarrassment. About the avoidance behavior I talked about, how does that really interact with the auditing environment? Research has shown that review and accountability processes actually leads to reduction in psychological biases. So this is good. There's been a lot of research on this topic. But there's also been examples of the opposite, where a salesman engage in avoidance behavior even though they know they shouldn't to sell the product. Also, there's been emotional reactions documented in capital budgeting and risk-taking and decision-making. So preferably, as we will see in this paper, there are consequences to our psychological biases. So preferably, we want auditors to exercise their professional judgment in the right direction. So if there are not good costs to their psychological biases, then they would try to inhibit them. And what about electronic communication? Research has shown it mitigates the reluctance to express opinions found in face-to-face communication. So that should be good in an auditing context. It reduces situational pressure or accountability. It also allows rehearsal. It avoids immediate feedback. And it's also more convenient. So in this situation, because we're talking about auditors asking client management for evidence, it's perhaps less intrusive on manager time in the context of this research, which is a good thing. So before the researchers actually went ahead with their experiment, this paper is kind of two parts. They also wanted to do a survey in that they wanted to gauge reactions, like real-life situations, in how auditors perceive their interactions with management in the collection of audit evidence. So they surveyed 28 staff-level auditors. They had up to 2 years of experience, which shows they are actually very fresh new auditors, only staff because the upper bound is 2 years of experience. So the results show that auditors reported that 86% interacted with client management 30 or more days a week. This is a lot. Shows there's frequent client interaction. So preferably we would want the best kind of client interaction possible. So staff were the second highest group in terms of interaction with client management. The highest group was, of course, senior staff auditors, so one level up, and which is, I guess, surprising because we always think that partners have a lot of interaction with client management. That actually is the seniors and the staff who spend, like, I think they spent around 30%. They said all the levels in an audit firm that they calculate the time that they spend with client management. I think partners spent like 10% of the total time of the firm, and seniors and staff spent about 30% each. I think that sure. Yeah. Okay. So fieldwork.
Because partners don't do any work, correct? And even the manager of the engagement, unless it's a very big engagement, also doesn't do any work. The people that are there and see everyone is Andrea.
Yeah, it's interesting because I talked to my friend who also works at auditor. So she tells me that auditors, like seniors, do all of the work and then they check all of the work. But here, they're also the ones that interact with the client, right? So they really do
They do everything.
yeah.
My wife was CFO in too many organizations, complained bitterly about external auditors. They say we have to teach them everything. Every year I train someone, next year the next guy comes. And it's low risk engagements because they were education institutions. She was CFO against institutions. But I think she basically was interacting with juniors and seniors, staff accountants.
Yeah, exactly.
And she was CFO, so.
And yeah, it's I guess it's a bit surprising to me that fieldwork is perceived as invasive by both management and the auditor. So it's kind of like even the auditor feels sorry and recognizes that they are, infringing on the client management side. They also rated client management as having more accounting knowledge, professional accounting experience, and industry-specific knowledge. So the industry-specific knowledge is very high. We can understand that, but I mean, I guess because really it's staff level auditors that did the survey. They also saw management as actually being more knowledgeable than them, even though they're the ones that are supposed to provide the assurance. So that was a bit interesting. Right. Yeah. So this is like some questions that were asked during the survey. I asked several of the ones that I thought were really interesting. So in 100% of the participants that were surveyed, they said that they noticed that by the end of the discussion, the tone of the client management or attitude of the client management seemed to indicate that he was annoyed with you in your interruption of the story.
Did you have to make auditor face at that moment? She has a very ferocious auditor face.
No, but it's true. They lose patience with you because your wife is right. There's so much turnover, right? So they have a first year that's fresh out of college and they don't really know what they're doing, and you're talking to someone that has been doing the same thing, the client, for 15, 20 years. Mm-hmm. So it is intimidating. It is understandable why they get upset.
And if you are going to do a study comparing internal and external auditors, that would be a facet where internal auditors would be much more comfortable.
Yeah.
And I like to write my articles talking about auditors, neither internal or external, and I always have an argument with Denise and Alex about that. And they say, we're only talking about external auditors. And they are right. They are right. I'm wrong. Right?
Right, and then also in 50% of the time, they report that you're working on areas of audit in which you have little prior experience in discussing the audit test work with the client. mean, I don't know how much that reliance is. I would also think that they reported only 50%. So the actual amount of auditors who actually rely on their clients' work is higher than that. And like I said, it depends on what you're relying them on, right? But if it's like you're just basically not checking your client's work, that's probably not. Especially in conjunction with the results we saw before, right? They said that they thought the client had more accounting expertise, had more industry expertise, which was probably true, but it still doesn't mitigate the factor that, if the client actually wanted to commit fraud or something like that. Or
on the 28th, you can drill Marina about how a client feels about being audited by internal and external audit. Ask her, see what she will tell you.
But, yeah.
You can ask in Chinese, so I don't know what she's asking.
So that's the first hypotheses that the researchers have. They said ceteris paribus, participants will be less likely to request additional audit evidence from client management who is older with more knowledge and experience than from client management who is similar in age and experience, which they saw as, so we had before all the psychology research on avoidance behavior. The psychology literature has shown that if the client is seen, as we said before, difficult situations, difficult people, then it's more likely to have avoidance behavior. And then from the results, actually, from survey results additionally. So it seems like client management who are older with more knowledge and experience may fit that more intimidating situation a little bit better. So that's the first hypothesis, H1A. There's also H1B. Participants will be less likely to request additional audit evidence when client management has explicitly behaved in an intimidating manner than when the audit client has behaved neutrally. So that's like an expansion on H1A. And there's also two additional hypotheses that mostly focus on electronic communication. It says participants will be more likely to request additional audit evidence via email than they will via face-to-face interaction. And the difference in evidence collected between email and face-to-face communication conditions will be greater for those participants who meet with an older, more experienced client than for those who meet with a client of similar age and experience. So that's like H3 is interacting, the intimidating condition, and also the email versus face-to-face condition. And they think there will be an incremental effect if you have the interaction. So the experimental design actually uses 138 master's accountancy students. They simulate a risk and reward scenario where quality of work was graded, so that provides incentive to auditors to actually behave in a way that they would behave in a real life situation where they're trying to collect audit evidence. In the case itself, it's about an accounts receivable confirmation. The goods are in transit at year end, and the terms are FOB shipping point. The invoice and shipping documents were provided. The auditor actually needed additional contract to verify shipping terms. So that was a question there of whether they would schedule a third meeting with the controller to obtain this document that they needed to actually verify the shipping terms, which was what they should do under the situation. It's a third meeting because I think the first meeting was just to meet the controller. The second meeting, they had conditions. They actually manipulated the conditions. So the controller said something that was intimidating, or they saw that, or they interacted with the controller and then had a little bit more insight into, like, if they had more experience or if they were just similar experience with the auditor themselves. So the independent variables in depth are the controller type, the older and knowledgeable with significant accounting experience, so that was simulated a social mismatch. There's an older and knowledgeable with significant accounting experience, and the auditor was also, the client management was also very intimidating. They said things that were very intimidating. I think I didn't put they said, like, so they would say something like, we counted for this way, did you learn it in your accounting class? So I thought they really tried to manipulate the different situations between intimidating and non-intimidating, because some of the things they said were a little bit intense. And there was also matched client management with auditor in terms of age, knowledge, and experience. So that condition was, I guess, kind of like the baseline or something that was not intimidating in any aspect, like no social mismatch and no actually explicit intimidating words either.
I think the contour was Jamie.
And they also, the other independent variable, because I think this was a 2x3 experiment, there was also face-to-face versus email communication that they could request. So they could only request one or the other. They can't say, oh, I don't want face-to-face communication with client management, I only want email, because it relates to the dependent variable they had. The dependent variable was just binary in that they did the auditor actually request that third meeting in terms of trying to get more evidence or not. So these are the results on the auditor's perception of client management. I have several things that, again, I thought were interesting. Do you think, well, we can see mostly that the intimidating condition had the lowest values of approachable. The lowest values of approachable, the highest values of impatient and annoyed, lower values of easy to work with, respectful, that kind of thing. But what I thought was interesting was that between the non-intimidating group and the similarly matched group, the similarly matched group was actually rated as much, I think, quite a bit, because the p-values are less than, almost all, are less than 0.001, so very small p-value shows that there was a significant difference between similar match and non-intimidating in terms of respectful, which I think just by how they actually set up the conditions, it doesn't seem very obvious at first why the similarly matched client would be more respectful, because they got the same script. Like the non-intimidating and the similarly matched got the same script. So I thought that was just an auditor perception, just because, I guess, of the social, like there was no social mismatch in the similarly matched condition. So that was the same thing with willing to help. I felt like because some of the other conditions, it made sense that, for example, approachable, it definitely made sense that the similarly matched would be seen as more approachable than the non-intimidating, but not so much for like respectful and willing to help. I felt like that was just more of an emotional aspect, which actually I will get to like near the end, which I think is I had a bit of a question of how they designed the experiment because of the results that we see here. The researchers also mentioned that, and I thought this was interesting as well, in that they saw the intimidating client as the least credible, and then it goes more and progressively more credible after that. So the non-intimidating is a bit more credible, and then the similarly matched is the most credible. So the p-values here in the last column, B to C is about 0.07. I think that's still a relatively small p-value because it would be significant like at the 10% level. It shows, the researchers mentioned this because it showed that it should work against their hypothesis, in that they said that if the client was seen as more intimidating, they would request less evidence. But if the client is seen as less credible, then they should hypothetically request more evidence because it seems like they can't trust what the client's seeing. Right, so that was just what I mentioned before. And the results they showed I thought it was interesting in that there was no significant difference in evidence requested between non-intimidating groups for the older, more experienced controller. So the H1B was not supported. I thought this was comforting in a way because it showed, I guess, there was some sort of professional judgment at work in that if your client was treating you in a manner that seemed to indicate that they were more emotional about this topic, but you as the auditor would not really factor that into like your actual collection of audit evidence. However, so this is their main hypotheses that they were tested. They tested H1A, which was the social mismatch condition. Like if the client was older and more experienced versus if the client was similarly matched, there is a very significant effect in the frequency of meeting that was requested, so the binary variable 0, 1, and also in both situations. So both email and in person, we can see the difference there would be similar match in older experienced controller. So similarly matched, 82% actually asked for an initial meeting, but only 35% for in person, and then also 90% requested an email meeting if it was a similarly matched client, and 68.75% requested an email meeting if it was with older and more experienced controller. So it shows that definitely, even though the non-intimidating versus intimidating situation didn't show any significant effects, but just by virtue of your client management being looking or showing that he is older and more experienced, the auditor is actually significantly much less likely to request an additional meeting and actually do the work that should be done under professional judgment to get the audit evidence that is needed to make the correct conclusion. So that's the test of H1A here. This in-person meeting is especially significant because you can see it drops from 82.61% to only 35%. So I think that's less than half of the people that requested it in the similar match group. And then so they also wanted to test some additional hypotheses in that does the communication mode actually matter? Well, the test here of the p-values shows that communication mode actually matters as well because they had they compared cell 4 and cell 3 for the similar match controller, and it showed that they also had, like, I guess this wasn't particularly significant, but if we look at the values, actually more auditors requested email meetings than in-person meetings, and the effect was not so significant for the similarly matched controller group, but very significant for the older and experienced controller group in that they were much more likely, of the people that actually requested the meeting, which was not that much in the first place compared to the similar match condition, much more requested an email meeting than an in-person meeting, which I think it shows, so the simple effects here were very significant, and then they also wanted to test, again, the H30 of the interaction, which shows that that is quite significant as well. It would be significant at the 5% level. Which we can see just from the values here, because the simple effect shows that for the similar match condition, it's not so significant, but for the older, more experienced condition, it is definitely significant. And they also did additional analyses where they asked the participants what kind of conclusion they would actually make in their audit report on like whether they collected evidence or not, whether they requested a meeting or not. I thought this was quite interesting. I mean, this is the important part because we actually want to know what the auditors did with their perceptions. They showed that auditors, a lot of them, even though, so they highlighted, I don't know if it was bolded, yeah, you can see it a bit. So the bolded was the correct conclusion that they were supposed to make. But here, we see that in auditors who did not obtain any additional documentation, which meant that they didn't request a third meeting, a lot of them actually concluded B, which says that according to the shipping terms with the customer took possession of the goods on 12/31/08. So new technologies has properly accounted for the sale receivable at year-end, no exception noted. So this isn't actually the correct conclusion that they should make, right? Because they can't conclude that the sale and receivables were correctly accounted for at year-end because they actually did not get the documentation. So it could be seen as the auditors actually not fully making a truthful statement on their what they wrote in actually the work that was completed. Also, the ones that obtained only an invoice and shipping document but not a contract, a lot of them also concluded on B, which again shows that they perhaps were not entirely truthful in their actual audit evidence collection process. However, I have a bit of questions on how they actually administered this part of the exam. So I thought the results were very interesting, but I just, the process, I wasn't entirely sure about it, in that I wanted to ask if all 4 options were given. Because if the auditors were able to write their own conclusions, then they might conclude differently if they saw all 4 of the options. Because if they saw all 4 of the options, I'm assuming they have an idea of what is the correct answer that they should write. And because we said before there was actual risks and rewards associated with this, so they might choose an answer that they thought was correct, but it's also not a full reflection of reality in that if the auditors were actually doing the thing, they would probably not have access to all these conditions, and perhaps they would be a little bit more conservative in how they documented their process. That's just my question. Also, I had some additional comments after reading this paper. So the math class also rated highly on social interaction variables, which were the variables I stated earlier. I think it was willing to help and being respectful. So I wanted to know really what was the decision-making process. I thought, is this an opportunity for full verbal protocol analysis? Because actually liking your client management might induce different reactions than seeing them as intimidating. I think that was a slightly different situation there. And I was wondering if do the materiality of the accounting question matter? When the researchers ran the experiment, they didn't really specify how important this shipping, I think this accounts receivable that they were reporting was to their whole business. I thought that would also influence how auditors actually perceive, if they were to request additional meeting. I definitely think if the materiality was high to a certain threshold, they would request a meeting no matter what. So perhaps in this situation, it was just because they thought it wasn't very important, maybe it was a very, very small amount, so that might influence how the decision. I just wanted to see the boundaries, for example, in where your psychological biases would take effect or your professional judgment would actually rule out your decision-making process. And also, right, so I was also interested in why it doesn't change for intimidating versus non-intimidating. I think there's an extreme lack of credibility in that we saw that the intimidating situation had the lowest credibility. So was it things like that actually mitigated the social interaction effect? And then, so maybe the auditors thought that they were not credible in intimidating condition, they're really not credible in an intimidating condition, which was why they decided to request about the same number of meetings anyways, because like, I guess that is a preferable judgment because their actual professional judgment came into play and they said, well, it was because the client is acting this way, it seems like they're even more not credible. So we would still treat them as we would treat a non-intimidating client. And I think that is all from my presentation.
So how credible is, I don't know, who was the intimidating person? Was a colleague who was playing the role? I don't remember that exactly.
I think it was a colleague, yeah. It's always
So how intimidating can a colleague be? How intimidating Jamie can be? Very intimidating, it's a tough guy. So I think that, you see, this might, first, this out into the accounting review. We like that. Second, I agree with Selena. This is actually a nicely designed experiment. I'm not very keen on this type of behavior studies, but I like it. I thought it's good. Good paper, I got an accounting review. But, you know, in my whole career, I spent 15 years doing behavior research. In my whole career, there was this discussion, paper by Cunningham, there are pilot papers, students versus professionals. Do you use students? This is a typical study that you can't use students. Right? How well can you emulate a client auditor interaction in a simulated environment?
Well, this was kind of a question for maybe Andrea could answer. When you get
A little bit louder.
Oh, this is a question that maybe Andrea could answer. When you get training to be an external auditor, do they instruct you when you go to work for a company to kind of ignore client intimidation and things like that?
I wouldn't say they instruct you to do that, but I remember that we had like a simulation mock of going to do a walkthrough meeting with the CFO, and it was the CFO's job to be like really mean and cranky, and you're supposed to do your job and get the right evidence. So I guess to answer your question, I guess they
Because
did.
students may not, if they don't have that kind of training, they may be less likely to perform. Although the research obviously found there was no real difference between intimidation and non-intimidation. My other question is there usually a difference in experience between internal and external auditors, like on average?
That's true, correct? Meaning, internal auditors are in the same company, so they will review the same system or etc. over their careers there, and typically in the CPA firms it's an up or out kind of thing, but in internal audit it's not that way.
So internal auditors tend to have more industry experience on
They
average.
typically will know better the environment, they know the industry better. I think the direction will be very different.
Yeah.
At least that's what some of our research. But my main objection to this paper is the use of students on this. And you know, usually I'm the advocate exactly the other side. I always say my journal, my JAR paper, decision styles, learning patterns, and etc., is with students. Okay, and I argue that your basic learning pattern doesn't change if you are a professional or you are a student. But this one, intimidation, meaning how intimidated. Just imagine Ben being a nasty supervisor. Not too credible, correct? I wouldn't be too afraid of Ben. Okay, but so in this, that's my problem in this paper. Otherwise, I thought it was very nicely done. And one other thing, I thought the results were a little bit too good.
Professor, can I add something here? For the young auditors, there are this research is supposed to the intimidating client, but the real thing is they are waiting for the intimidating reviewer or partners if they neglect their job, the more intimidating or more scary the reviewers waiting for the young auditors, and
That's a good point.
Yeah,
There are two intimidating
scored by
factors.
the-
There maybe the second one is more, the partner is more intimidated because it has effect over their career.
yeah, and
Good point. I
they
didn't
just
even think
reviewing
of
the
that.
process, they neglect their young auditor's job, and they severely scolded by the reviewers.
But
Yeah,
you
I
should-
didn't even think of that. That's a good point. But it's a nice study, isn't it?
Actually, to your comment from before, when I first saw it, I thought like master's of accountancy students, maybe not the best example. But here, when I think back on it, because I feel like, because I did accounting in undergrad, I feel like a lot of them also talked about talking to controllers when they were doing their internship and also when they just graduated. So I think the age is not a big problem here, but I thought like this situation is not the best. Like they didn't emulate it the best that they could have, because actually being at your client and then trying to get evidence from them is probably different than you sitting in an experimental classroom and be talking to another, like you said, the Confederate, and being like, okay, you need to do this. I thought that part was a little bit hard to actually replicate. So maybe that was what resulted in the results being.
So guys, you do something like this, you get it in the accounting review. Correct?
Easier said than done.
You better want it in the accounting review if you want to stay in this career in a good university. But it's a little bit of a trivial discussion. It's very interesting. I think I agree with Selena. When you first see, say, what's this? And then you read it carefully, it's quite interesting. Very interesting. And that's why I put it here. We're talking always about technology. Let you guys look at a couple of behavior papers. Now, one comment, not on this paper. The two papers before, basically the Vasarhelyi, Brown Vasarhelyi paper, and the other one, they were kind of developed about the same time, and they're very complementary. Okay, we did a lot of arguing at that time, and I can't even remember which one got published first. That was basically at the same time, and basically the same discussion of evidence. One a little bit, you see, one had Lucas on the group. Lucas is a KPMG person, very technical. Okay, the other one was Helen and me, more academics. So I think if you read those two papers, you got a very good feeling for the questions of evidence and big data. Okay, guys, see you next week. You are permitted to drill Marina as much as you want about intimidating clients.